for mechanical engineering. So here we are discussing the fluid mechanics solution, fluid mechanics and hydraulic machine solution for set E. Now here we will be starting our session with the question number 1 for this fluid mechanics. The velocity field of a certain two-dimensional flow is given by the velocity vector is given as v, which is nothing but kxi minus yj cap, right here kxi yj cap, and where k is nothing but 2 per second, and x and y are in meters. If the fluid density is 100 kilogram per meter cube and pressure at the origin is 10 kilopascal, what is the pressure at point 3,3? So again, this question has been asked recently only in GATE 2023 in mechanical paper. This question has been, with the little changes in the data, but the exact same concept based question already been asked in GATE 2023, guys. So here what to do? Here we need to proceed this question with the what? Navier-Stokes equation, right? So here what we can write here? Velocity vector. So what is the velocity vector? Kxi minus kyj cap. Now if you see very carefully, what are all the things we have here? What is the u component of velocity? U component of velocity is nothing but kx. And what is the v component of velocity? Minus ky. If you write down here x and y. So here we have u component. Here we have v component. Here we have v component. Now coming back to the next part. Yes. Now here, what we need to do, we need to use the Navier-Stokes equations. So I'm writing what? X momentum equation. X momentum equation. If you write down the X momentum equation, what you are going to get? Here you are going to get a u by 2x plus v. Let me just open the question, just a moment. Yes. So here we have u by dou x plus v dou u by dou y plus omega dou u by dou z plus dou u by dou t. That is equal to minus 1 upon rho dou v by dou x plus mu by rho del square u by del x square del square v by del square u by del square u by del y square plus del square u by del z square. Now, if you write down here u, what is the u? Kx. Dou u by dou x. What is the dou u by dou x, guys? It's a k. And what is the dou v by dou y? It's a minus k. What is the dou square u by dou x square? 0. What is the dou square u by dou square v by dou y square? It's a 0. In fact, dou square u by dou y square, that is also going to be 0. This is also going to be 0. This is also going to be 0 because now the flow is 2D flow. So nothing is going to be vary in the third directions, that is z directions. If you take a z directions, nothing is there, right? W is not there. This will be 0. It's a steady flow here. And here we have dou u by dou y. Again, dou u by dou y is 0, right? So here kx, then what is the dou u by dou x? We know that it's a k. Minus 1 upon rho dou p by dou x. Dou p by dou x. Now here, what is the dou p by dou x? Minus rho k square into x. Minus rho k square into x. Now what we need to do, we need to integrate it. Whenever we do integration of any partial differential equations, we need to add not constant, we need to add some function of variables. So here, what is the p? P will be minus rho into K square into x square divided by 2 plus some function of y plus some function of y. Because here we are differentiating with respect to x. So anyway, if you try to differentiate and go back to this one, you will get same equations. This is the equation number 1, for example. Again, what I'm doing, I'm writing y momentum equation here. Y momentum equation. What is the y momentum equation, guys? U into dou u by dou x plus v into dou v by dou y plus omega into dou v by dou z plus dou v by dou t, that is equal to minus 1 upon dou p by dou y plus mu by rho del square u by del x square del square v by del y square del square v by del z square. Now here, guys, try to substitute into the formulas. We know that u is what, kx, v is what, minus ky. What is the dou v by dou x? Uh, Here we need to find out dou v by, what we need to find is dou v by dou x, which is obviously 0. What is the dou v by dou y? It's a minus k. So v is what, here this sum is 0. What about this v, guys? Minus ky. What about dou v by dou y? Again minus k. Minus 1 upon rho dou p by dou y. All this term will be again 0, because if you differentiate of any constant, it will be 0. Now here what we can get, guys, p, again dou p by dou x. What is the dou p by dou x? Minus rho k square into y. From equation 1, guys, if you see, what is the equation number 1? Already we have written. P is equal to minus rho into k square into x square by 2 plus some function of y. Try to differentiate equation number 1 with respect to, this is what dou p by dou y, guys. This is dou p by dou y. Try to differentiate this equation number 1 with respect to y. With respect to y. If you try to differentiate, what you can get? You will get minus rho into k square. This term will be 0 plus f dash of y. Right, guys? Now, so what is the f dash of y? That is a minus of dou p by dou y. Or we can get dou p by dou y. What is the dou p by dou y? From here, minus rho into k square into y. Try to integrate this total differential equations. Definitely you need to add the constant. So what is the f of y? F of y, you can get it like minus rho into k square minus rho into rho into k square. Now what we are doing, we are integrating with respect to y. So we are going to get y square by 2 plus some constant k. I'm calling this as constant. Now put that f of y into the equation number 1. If you put f of y into this equation number 1, then what you can get, guys? P is equal to minus rho into k square by 2 x square plus y square plus some constant. Plus some constant. What they have mentioned in the problem, they have given in the problem at x and y, which is nothing but 0 comma 0, the value of pressure is what? 10 kilopascal. That is 10,000 pascal. Put that value and get the constant, guys. So you can get like here it's a 0 0. Then constant will be what, guys? Constant will be 10,000. Now put that constant value and try to find at 3 comma 3. So what is the pressure value at 3 comma 3? Minus rho. Rho is what? 100. K is what? 2 square by 2. 3 square plus 3 square plus some constant is what? 10,000. So what is the pressure value at 3 comma 3, guys? If you try to see and observe very carefully, and 100 into 4 divided by 2 into what, guys? So you are going to get 6400 Pascal. But they ask in the problem, if you see, they have asked in kilopascal, so 6.4 kilopascal. B should be correct. So what are the two things we have learned from this question? Whenever you are integrating any partial differential equations, you need to add some function. Whenever you are integrating any total differential equation, you need to add some constant. That you need to remember. Moving back to the, again, question number 2 here, regarding this fluid mechanics. Spherical, please read this particular problem. Spherical water droplet, please try to read this one. A spherical water droplet of diameter 2 mm, diameter 2 mm, is split into 8 small drops of equal size at a temperature of 25 degrees centigrade. The surface tension is 0.073 Newton per meter. The dynamic viscosity is what, 0.01 poise. 1 poise is what, 0.1 Pascal second. Pascal second. Then what they have mentioned, guys? Approximate work done in splitting into 8 small droplet. So you need to remember directly formula, guys. Work done for splitting into 8 small droplet. So what is the formula? 4 pi r square into sigma n minus n to the power 2 by 3, where r is what? Small size droplet radius. Small size droplet radius. N is nothing but number of drop 8. So first of all, they have given the big droplet, which is having a diameter like a spherical water droplet of 2 mm split into 2. So total volume will remain same. If the total volume will remain same, guys, then what we can write? If the total volume will remain same, then what we can write, guys, here? For here, what is the total area? If you try to see, 4 pi here we have. See this particular formula, whatever the formula I have written, this is the formula to get the work done, from a n small droplet to get the big diameter. But here the question is reverse. They are asking if you want to split the large droplet into the smaller droplet, then definitely we need to change this formula, right? Now, what should be the formula here? The formula should be, this formula should be somewhat different, because whatever the formula just now we have discussed, this is the formula for converting basically to get the work done, you know, to convert any small droplet into big droplet. But here they are asking reverse. So 4 pi r square into sigma n to the power 1 upon 3 minus 1. This should be formula, guys. Here r is what, guys? R is nothing but the diameter divided by 2, which is nothing but 1 mm, 10 power minus 3 meter. So 4 pi r square. What is the r square? 10 power minus 3 square. Sigma is what, guys? 0.073. N is what, guys? N is 8 to the power 1 upon 3 minus 1. If you try to substitute directly, you will get 0.92 into 10 power minus 6. Here there is no role of viscosity here, right? Into. B should be correct. B should be correct, guys. That you need to understand, right? Now there is one more way to get the answer for this question. Work done, we can also write sigma into change in surface area. Change in surface area. Ultimately, you will get the formula from whatever the formula I have written. This formula you can get from here only. Now, change in surface area. How the surface area is getting changed from a big droplet of 4 pi r square. That is the initial surface area. What is the final surface area, guys? The final surface area is n times of 4 pi r square, where r is what? Small size droplet radius, right? You can get the same answer from this also. Now, guys, please try to see this 18th question. 18th question is basically of 18th question is basically of what we have here is from the civil. So mechanical, we generally don't, study this particular rectangle open channel flow. But here directly you need to remember the answer for this question as C. The depth of flow will be half of the width of the you know channel for economical design. So that what is the meaning of economical design? So that we need to put less surface area, overall surface area. So if you try to get the derivations, if you go through the derivation, you can get the depth of flow that is equal to width divided by 2. This would be correct. Now, try to see this question, guys. Rapid, rapid and sharp changes in the fluid property in a very small region of the gas flow is basically what this shock waves. Now, understand. You know that whenever we discuss convergent divergent nozzle, this is the what we have the nozzle portion, divergence. This is the throat portion. Now, understand one more thing. What is happening here? Whenever shock waves are happening, the shock waves are always happening from a supersonic flow to subsonic flow, and that very well from the compressible fluid flow chapter that whatever the if you try to see the pressure variations, if I draw, so pressure will be decreasing, for example, because velocities keep on increasing, Mach number more than one. Suddenly, the moment flow is crossing the throat, no, throat section, definitely what happened? There is a sudden changes in the property, and then Mach number will reduce. So flow will happen. No, basically flow is getting converted from supersonic flow to subsonic flow. There is a sudden changes in the property. If you see the pressure versus X variation, pressure was decreasing, velocity was increasing. But the moment there is a shock waves are happening, suddenly there is a sudden changes in the property. What are all the sudden changes in the property like pressure, density, temperatures? All will change, guys. All will change, right? So what you can write? And sudden change, or what we can write here? The sudden deceleration of a gas. Sudden deceleration of a gas from a supersonic flow to subsonic flow during which pressure, velocity, density, etc. all will rapidly change. All will rapidly change. Right? You can see there is a sudden jump in the property because of shock waves. And that will only happen in the divergent portion. That can never happen in the convergent nozzle. Right? Okay. Let us move to the next question now. Try to see this question, guys. One of the very easy question. A cylindrical body of diameter 2 meter. If I write here, if I just draw the rough diagram, a cylindrical body means solid cylinder, for example. Solid cylinder which is having a certain diameter 2 meter, right? Which is having a certain height of 1.5 meter, having a mass of 2 ton, which is nothing but 2000 kg. And see, basically, it is floating in a sea water with axis vertical. That is what we have drawn. A lighting equipment, a very light equipment. Let me mark it with a red color here. This equipment has been placed, which is having a certain mass, small m, for example, is placed on that particular body such that the water level is at least 0.5 meter below the top surface. That means here. this much of depth of cylindrical surface is immersed in the liquid. So what is the total height from here to here? It is a 0.5 meter, and this will be 1 meter, guys. What is the maximum mass of the electrical equipment that can be placed on a body? They are asking. Pi value they have given, and they have taken specific gravity as 1.02. So what we can get, guys? It's a very easy question. Whatever the weight here, whatever the weight is there of total object, that will be balanced by buoyancy force. Total weight will be basically what, guys? The total weight will be balanced by buoyancy force. What is the total weight, guys? 2 tons is there plus some mass small m into g 9.81. That is equal to weight of the water which is getting displaced. Weight of the water getting displaced. Weight of the water which is getting displaced. What is the weight of the water which is getting displaced, guys? Everybody know that. What is the weight of the water which is getting displaced? Rho g into volume of the displaced liquid. So 2000 plus m into 9.81, which is equal to what? Rho. Rho of volume of the liquid which is getting displaced. What is the volume of the seawater? Volume of the seawater is what? Rho g into v. But what is the rho? It is 1.02 into 1000 into 9.81. What is the volume? Pi by 4. Tell me, guys. What should be the volume here? Pi by 4 d square into L. How much of depth which is getting immersed here? The depth is getting immersed 1 meter. If you see 1 meter depth is getting immersed, h dash. So pi by 4 d square. D is what is the diameter, guys? 2 meter into 1. Height is what? 1. If you try to calculate small m, you are going to get 1202 kg. 1202 kg. So which option is correct, guys? If you just go through, C option is correct. By looking at the theoretical, whatever the explanation they have given in the problem, no need to get fear. Only we need to make the diagram and then we need to get the answer. Coming to this question, guys, examine the following statement. What is the following statement they have given? If you try to just go through this one. The Euler's equation is applicable to inviscid flow. It's absolutely correct. The Bernoulli equation is applicable to steady state. It is one of the assumptions. The viscous forces are not considered. Yes, it is considered. It is wrong. Because in the Navier-Stokes equation, we need to consider pressure force, gravity force, plus viscous force. What about Euler's equation? We are only considering pressure force and gravity force. We are not considering any viscous force. Surface tension and compressibility forces are considered in the Navier-Stokes equation? No. These two forces will be considered when we talk about the Reynolds equations. And compressibility we are discussing when the velocity of the fluid is very, very high. That is when we are discussing the Mach number. So again, by looking at this first and second statement is correct. But if you just go through the options, none of the options are matching, right? None of the options are matching. So what they will do, they will decide to either eliminate it or they will give marks to all. Okay. So this is, guys, regarding the fluid mechanics. Yesterday we were discussing about the strength of material, and I will try to take a few questions of two questions we left with the simple question of strength of material that we will try to cover it. Now try to see this question, guys. What they have asked. They have asked this particular question from the machine design specifically. A flat belt run over the pulley, which is transmitting the power 2.5 kilowatt. A linear velocity of the belt is 2.5 meter per second. The angle of lap is 165 degree. The coefficient of friction between belt and pulley is 0.3. The initial tension is increased by 10%. What is the initial tension? T naught, T1 plus T2 by 2. If we take T1 common, then what you can get, guys? T2 by T1 by 2. So T1 1 plus 1 upon e to the power mu theta by 2. If you take T1 common, so you are going to get something like this. Because what is the T1 by T2? It is the e to the power mu theta. If you take a belt, something like this. This is what we have angle of wrap theta. Angle of wrap theta, guys. Understand, it's a very easy question. Don't get fear by reading this statement of the question, guys. This is the initial tension. Initial tension, they are saying that it is, see, everything remain constant. They are only changing the initial tension. Initial tension T naught 2 become what? 10%. That means 1.1 times of T naught. That's it. So what about T1, guys? T1, because mu theta will remain constant, then obviously T1 will also increase by what? 10%. Definitely, it will also increase by 10%. If T naught is increasing 10%, T1 from this equation, let's say this is equation number 1. From the equation number 1, we can see very clearly mu theta will remain constant. So only T naught will be the function of T1, right? And what is the power formula? T1 minus T2 into V. But we know that if you take T1 common, then I will getting what? E to the power mu theta into V. V we are not changing. Mu theta we are not changing. So again, power is also function of T1. If T1 is increasing 10%, then power will also be increasing by what? 10%. A will be correct. A will be correct. What they are asking is the property of the material that represents the maximum amount of strain energy that it can absorb before the fracture, under the load, is called, guys, what we call the property of the material that represents the maximum amount of strain energy that it can absorb before the fracture under the load is called modulus of what is modulus of toughness. Area under stress versus strain diagram. If you plot for any ductile material, for example, up to the fracture point, whatever the energy which is getting absorbed, area under this curve, area under stress versus strain curve up to F will be the modulus of toughness. What is the modulus of what we call resilience, guys? Again, the modulus of resilience basically area under stress versus strain diagram up to the elastic limit. This particular area, whatever the area we are going to calculate, this area, my dear friend, this is called modulus of resilience. Modulus of resilience, and it is a property of the material. Modulus of resilience. And whatever the total area is there, the total area will be called as modulus of toughness. Right. Remember, these are the proof resilience. Modulus of resilience is proof resilience per unit volume. Right. And whatever the toughness per unit volume, the toughness per unit volume is modulus of toughness. Right. So these are the two properties of the material. The answer will be B. So that is all about, guys, strength of material and fluid mechanics solutions. Right. Thank you all.